Hey, you astronomy kids. This is Mr. Johansson. I'm talking about the third question on the Astronomy Aerospace Final. This question is asking, what was the Copernican idea and what was its advantage over Ptolemy's idea? Well, we have to go back and remember what the Greeks, and notably Aristotle, had said about motions of the things in the sky and Earth's relation. Because of the lack of stellar parallax, we knew the Earth could not be going around the sun. They had made observations about all the nearby stars, and they saw nothing in them moving back and forth over the course of a year. If we were in fact going around the sun, you'd expect nearby stars to have a motion, just like if you swap eyes when you hold your finger over something, your finger appears to move. As the Earth moves around the sun, we would expect those stars to move. They didn't move. We never ever saw that till we had really advanced telescopes. The thing that they missed, of course, was stars are incredibly, incredibly far away. So while we do see stellar parallax with telescopes and photographs of them, it's nothing you would ever be able to see with just naked eye observation. So what they knew, because they didn't have this stellar parallax and they had looked for it, what they knew is that the Earth stood still. Everything going on in space just went around us. That's not a problem. That's really not a problem. It's like the celestial sphere. Okay, we have the Earth down here in the center, and everything is just on the celestial sphere, and it just goes around us. That's hardly a problem until you pay attention to it. When you pay attention to it, you notice not everything stays in place. Night after night, there are certain bright objects that appear to move eastward night after night through the constellations. They appear to move to the east. They were called wanderers. The word was planetos. Planets. They appear to move to the east. Okay, somewhat of a problem. But the big problem was that not only did they move to the east, every once in a while they would seem to stop and back up and then continue moving to the east. So how do you explain that? Well, Ptolemy came up with, Claudius Ptolemy, somewhere around 140 AD, came up with a pretty remarkable explanation. What he said was that there are a series of crystal spheres with these objects on the spheres, and the spheres moved in relation to each other. I'm going to give you just a very ballpark idea of what he was talking about. So we would have the Earth here, the center of everything here, and the equant point is what they called it. And around the center we have a large circle. Coming from the equant point would be another circle, and the planet or whatever, well, it would really have to be a planet if it's doing this, would be on this circle. It wouldn't be moving this way somewhat slowly, but that would allow you to see why it would occasionally back up. And he had many of these nested crystal spheres. Sounds like a nutty idea, but he did the math so perfectly that he could really predict where these would be at any point in the future. So his ideas gained acceptance because of the mathematics of them. As a matter of fact, in a modern planetarium, we still use basically Ptolemy's idea to run the actual movement of the planets. We actually, the device itself is built off of Ptolemy's idea. So it's not a bad idea at all. It's a little nutty. It's a little nutty with all these crystal spheres. You can't see the crystal spheres. No reflection ever showed that there's a crystal sphere there. But they were all perfect circles, and it seemed to work in heavenly ways. And it was, for well over 1,200 years, that's what people did. So, Copernicus, Nikolai Copernicus, had a different idea. Copernicus had this idea that if you take the sun in the center and you have the planets in orbits around the sun, when one planet is passing another, right? If, let's do Mercury's orbit in here. So if we have Earth here, and Mars here. As they're orbiting this way, Mars seems to advance this way all the time, right? But if you're at a point where Earth is passing Mars, take a look at what happens. As Earth is approaching Mars, Mars seems to be in this point. If we have them both in their next points. Now, Earth is closer in towards the sun, means it moves faster. So eventually it's going to pass Mars. And this is what the whole thing is all about. So at the next point, all right, Earth is in the next point here. Mars is here. You can kind of see where this is going. All right, and as we zip past Mars, Mars seems literally to back up. Yeah. Mars seems to, at first it's going like this, then it would seem to back up and then continue, just because the Earth is passing it. You do the same thing every time you pass another car. As you're approaching it, the car seems like it's moving forward, but as you pass it, the car appears briefly to be backing up. So what's the advantage of this over Ptolemy's idea? Well, Copernicus still believed in these heavenly perfect circles for orbits, so he didn't predict anything better than Ptolemy's idea did. His predictions were as far off as Ptolemy's. But what his idea did have is something about it being simpler. And the idea of simplicity is held dear in Occam's Razor. An Occam's Razor is simply an argumentation technique that says if you have two explanations for an event, the simpler explanation is more likely to be correct. And clearly, Copernicus, his explanation seems much simpler. Now, we still didn't have stellar parallax, so there is evidence that the Earth is not moving, but that idea was very compelling. It also ran up against some church ideas, so Copernicus was quite worried about this and didn't publish until it was on his deathbed. His ideas were not widely accepted, but it did get people thinking, and eventually began the big swing to people looking for evidence that maybe he was correct. And they certainly found that evidence. So that's question number 3. What was the Copernican idea? Sun-centered, heliocentric, sun-centered, versus Ptolemy's idea, which was geocentric, the Earth being the center. And in Ptolemy's idea, the Earth was the center of the universe. Everything in the universe went around us. Now we understand the bigger scheme of things where, wow, we're talking galaxies upon galaxies upon galaxies. The Earth is one very tiny planet around an ordinary star. There are hundreds of billions of stars in our own galaxy, and there's trillions of other galaxies. So we know things are not going around the Earth. The Earth is no longer in a special spot. You're special. Don't let anybody tell you different. But the Earth's not in a special spot. And Copernicus clearly was more correct. Why wasn't he perfectly correct? Well, he still believed in these perfect circles. And we don't orbit in perfect circles. But he was more correct. Thanks for watching.